Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In this particular discussion, we're going to look at the second part of this specific operation for division of complex numbers. And in that case, I've just given of course, a representation for a phase of Z and W given in terms of the polar form. And we're going to do an evaluation for us to find basically the results which can be given for the division of the phase of Z and W given as such. And this is going to be giving us what we refer to as the result of a division of this complex number. Now, in a sense, we're going to see that we can have this one represented in terms of this specific aspect of R all over R. So I would like to remind us of a previous discussion which we had on basically the division or a multiplication of numbers which are going to be consisting of course, complex numbers, which we had mentioned basically that we can have this specific representation by having Z all over the face of Z all over W given in terms of Z, the face of Z all over W. But we're going to have this one multiplied with, of course, the polar or the complex conjugate of this specific denominator given in terms of W bar given as such on both sides of the equation, which can be represented as such. So in a sense, we're going to have this specific representation on the board given in terms of R, the cosine over theta plus the complex or the imaginary unit, the sine over theta given as such. And this is going to be a division over this one with the W, which is R, the cosine over phi, and plus the complex or the imaginary unit, the sine over phi given as such. So I've said that basically in this case, we're going to multiply by the conjugate or the complex conjugate of this specific denominator. And this implies basically that we're going to have this one represented in terms of this specific representation for R. So we shall have this one given in terms of R into the cosine over the cosine over phi minus the imaginary component or the imaginary unit, the sine over phi given as such. So I've just done a rearrangement by changing this specific sign for the, of course, numerator of this for us to cater for the complex conjugate. And we're going to use the same function for us to, of course, multiply with the numerator of this specific, of course, phase of Z given as such. And this is going to be given in terms of the sine over phi given as such. So doing our evaluation for this one is going to be giving us a division of this specific, of course, component of the two complex numbers. And therefore, this can be given in terms of the face of Z divided by W is given as. So we shall have these two specific sets of R and R given as a product of R given as such. And therefore, we'll proceed to multiply these particular components of the sine over theta plus the imaginary unit, the sine over theta, into the cosine over phi minus the imaginary unit, the sine over theta, or the sine of, so this is going to be the sine of phi from the complex conjugate given as such. And we are going to do this specific division with a multiple of this one given as the square over R. And then we're going to have the cosine over phi plus the imaginary unit sine over phi. And then we're going to have into the cosine over phi, the imaginary unit, the sine over phi given as such. So this basically is going to be forming our evaluation for the two complex numbers. And in this case, we're going to have this one represented through the previous forms of identity, which we had basically done in our previous video. And as we said, of course, we're going to have this one giving us a range of values which we can give. Perhaps we can just continue and do an evaluation for us to just identify that. So we're going to have this one given in terms of the cosine over theta, cosine over phi, and then we're going to have minus the cosine over theta, the sine over phi. But this one is going to be consisting of an imaginary unit given as such. And then we're going to have this second component, which is going to give us a third factor for the I, the sine, or the imaginary unit sine over phi, the sine over theta, cosine over phi, which is a multiplication between the second factor of this one and the first factor of the second part of the equation. And we're going to see that we are going to have this one, which is going to be basically multiplication of this one and this one, giving us a negative from this specific factor. But we shall have this specific component of the imaginary unit squared, which is going to be giving us the sine over theta, and then we're going to have the sine over phi given as such. Hope this one is legible. So we're going to have this specific component given as such. Basically, this whole aspect is going to constitute this first section and this, of course, third and fourth forms given as such. But we're going to do a rearrangement of this specific equation and try to see what we are going to come up with. So in our denominator for this specific case, this is going to be formed by having a multiplication of this specific set of functions. And I'm going to remind us from our previous discussion that if we have a factor which is going to be perhaps represented as x plus 1, so we're going to take an arbitrary factor whereby the cosine of phi is represented by x, and then the imaginary component, the imaginary unit, and the sine of phi is represented by 1. So this is going to be x plus 1, x minus 1. So in case we had this one, then it's going to be forming an analogous form of the difference over squares, and therefore we can have this denominator given in terms of the first, the square of the first component given as such, since we're going to have the common factors over phi. So we shall have this one given in terms of the square of the first component, which is going to be, of course, given in terms of r, the square of that one, and we're going to have the cosine over the square of phi given as such, plus this specific aspect which is going to be giving us. So we shall have this one multiplication of this one of course the two last of course terms for the two factors given in terms of the square of the imaginary, of course, units given as such, and of course we're going to have the square of the sine of phi given as such. So in this case, from our previous discussion, I've said basically that's going to be giving us a value of -1, and then therefore it's going to be having an implication that if we have -1, basically this is going to be giving us an addition sign given as such. So if we try to look at the section of our denominator, in this case, this is going to be representing what we refer as a unit from, this is going to be forming an identity, and therefore it's going to be representing a unit in this specific case. And in our previous discussion, we have mentioned that we can have this one given in terms of r, and then we are going to have the cosine over theta, cosine over phi. And I'm going to take the last term due to this specific factor, which is going to be giving us a negative, of course, 1. And of course, negative is equivalent to particularly a positive value, which you are going to be coming up with. And we shall have this one given in terms of plus sine over theta, the sine over, of course, phi given as such, and of course this is going to be the first and the last terms given as such. So we shall, of course, let's confirm whether that is going to be the same. So just do a cross check between this one. So we shall have this one and the last term given in terms of the summation of the two. And I've just done an adjustment for this specific aspect of the square of this, of course, imaginary sign. And then, therefore, we shall have the second factor given in terms of this specific evaluation. So we're going to start with this specific component, whereby we're going to have a plus this imaginary component into the sine over theta, cosine over phi. And this is going to be minus this imaginary component, and then we shall have this specific sign for the cosine over, the space is limited, the cosine over theta, and then the sine over phi given as such. And this is going to be defining for us for the four terms catered for the first and the last one, and the next two compressed using this general, of course, factor for the specific function of that one. And then we're going to have the whole of this one having as a denominator of the square of this one, since we have said this is going to be forming unit. And of course, this is going to be forming a result of the form which can be expressed in this specific form. So perhaps I'm going to do away with this so that we are going to have enough space for that specific representation. So we shall have this one given in terms of this specific components of r into. So for the first and the second case, the first and the second case, this is going to be forming, of course, compound angles, which are just mentioned for the difference of a cosine of compound angles. So this is going to be giving us the cosine over theta minus the cosine over phi, catering for this specific section from this one for the first and second term of this specific section. So this is going to be represented using this specific form of the cosine of theta, of course, minus phi. And then we shall have this second set of this imaginary component given as such. And in between here as well is going to be consisting of the compound angles which we had done from our previous discussion, which is going to be forming basically the concept of the sine of theta minus phi given as such. And this is going to be forming our numerator. So we shall have this one given as r to the square of that one. So we can simplify this one and have it given as such. So in this case, we are going to have this is specific representation as a division of the face of Z and W, giving us this specific answer for the, of course, evaluation for a division sign. So that is it going to be. So that is it for this specific concept. And I hope that we are going to be using the same concept in case we come across them in our various evaluation sets. So that is it for now, guys. Kindly check our description boxes for other links of other similar videos which are going to be assisting us in trying to, of course, comprehend this whole aspect of course, operations with complex numbers. So that is it for now, guys. By God bless you. Catch us in our next video.